Hey everybody, hope you had a great weekend. Um, Welcome to another Monday here in Mathland. Last week we talked about arithmetic sequences at the end of the week. We talked about, fix that a little bit. There you go. This is my daughter as Santa Claus, isn't that nice? We have all our Christmas stuff up, in case you were wondering. This is what we did this weekend. Wham. It's my favorite thing. So, yeah, wonderful. Outside lights are up too. I can go out and show you. Maybe if we have time. We'll see what happens. This week we are going to talk about scatter plots, lines of best fit. That's going to pretty much end Unit 3. Our test will probably be next Tuesday, is my guess. So, gearing up for test number 3. Obviously, it's a new quarter, and man, it's already the second week of the quarter, so we're moving right along. I think that we have 6 more weeks. 1, 2, 3, 6 and 2 days before Christmas break. So, and when we come back from Christmas break, I think we only have a week, 2 weeks, and that's your quarter. So, we're definitely going to be moving right along. I'm going to be going into Unit 4 here, and so just a heads up on that test coming up. All right, so we're going to talk about scatter plots, right? So if you don't know about scatter plots, a scatter plot is just a set of data drawn on a graph typically. So it could be any set of data really, where we have some data points going on, right? And yeah, you guys can see those maybe. Make them a little darker. So typically, if we have some sort of scatter plot, there's some sort of overall data that I'm looking for. So, you know, maybe there's some sort of relationship or an association that's going on. And there's 3 of those things that we usually talk about. This one right here is a negative relationship or a negative association. All right, a negative relationship is symbolized as 1 increases, the other decreases. So, in this case, if you look at this graph, as the x is increasing, the y values are decreasing, right? So this x value is like 10, but the y value is only like 3. This one has an x value of 2, but the y value is like 13. So, anything in the world that would be symbolized where is one's increasing, the other is decreasing. So maybe like the amount of time you spend doing cardio and your weight. As you do more and more cardio out exercises, your weight will decrease. So one goes up, one goes down. Or maybe it would be the temperature and ice cream sales. As the the temperature and winter coat sales. There you go. As the temperature increases, winter coat sales decrease. That would be a negative relationship. All right. Then, obviously, we would have a positive relationship. And that one would look like it would be increasing from left to right. So we would have something like some dots going on. Something like that, maybe. Yeah. So this would be a positive relationship. which means as one increases, the other also increases. Now notice that both of those times I mentioned that as they increase, I always think of it as if they increase. Because if they decrease, then they can also increase. Let me show you the example. The other increases. So here, as the x's get bigger, the y's also get bigger. Well, that's true. But you could also say, well, what about as the x's get smaller, the y's get smaller? That's true too. I just always think of it as one increases, what does the other do? Because they're an opposite, right? So as one goes up, the other goes up, that's positive. If one goes up, the other goes down, that's negative. So that's just how I think the easiest way to think of that is. Now notice that we could have outliers in our data sets, right? Maybe this is like an outlier where it has a very large y value as a very small x value. We're just looking at trends. Overall, what's going on in general with my set of data. Because if you look at any statistical study done ever, there is going to be some sort of outlier that didn't fit the rest of the trend. That's why you have that guy who talks really fast at the end of every medicine commercial ever, right? Because there were certain things that happened in their data that didn't fit the trend, but they have to tell you about them so that you don't sue them later. Like, oh, it could cause your leg to fall off. Like, that happened to somebody? Apparently. Otherwise, they wouldn't say it. So there's allowed to be outliers in your sets. But we're looking at overall trends. So a positive relationship, this might be an example of, easiest one is if you are an hourly worker, the amount of time that you work goes up, the amount of money you get goes up. Like if you work at McDonald's or something. Me, I don't make money hourly. Otherwise, I'd make double my paychecks, I feel like, this year. So the more I work, I make the same amount. But that's okay. That's fine. But anything else? The amount of calories you intake increases. The amount of weight that you gain increases. Temperature, ice cream sales. There you go. There's that one. So anything that you can think of as one increases, the other increases. The other third option would be what we would just call no association or no relationship. And that would be a truly scatter plot. Right? So something like this. And what's interesting is that this tells us a lot of information. It tells me that two things are not related. So when people spend lots of money on studies on if cell phones cause brain cancer, and they get something like this back, it's informative, right? We don't find a relationship here. So even though we think like, obviously, who cares? No relationship, obviously has no relationship. There's a lot of things today that we search for, like, I wonder if these two things are related to each other. And we spend lots of money putting statistical research together only to find out, nope, not related. All right, move on to the next one. So those are your three: positive, negative, no relationship. A no relationship would be something like your address number and your IQ. Just because you're really smart doesn't mean you live at 99999 Oak Street. Or if you are very dumb, you don't live at 1 Maple Drive, right? That doesn't make any sense. So maybe shoe size and bowling average, right? Like, just because you have big feet doesn't mean you bowl really well. So those would be no relationships. Now, with these relationships or associations, we can make what we call trend lines. So let me throw a negative relationship back up here. And some of this I'm going to talk a little bit more about tomorrow. But a trend line is like a line that I think can best represent what's happening with my data. And so we might call it a line of best fit. Now we're going to truly talk about what the best fit is tomorrow. But we can think of it as like, if I want a line to represent this data, there's a couple things I want. I want it to match the slope of the line, right? So you kind of understand what I'm saying. I can see that this is generally decreasing. But I'm not going to draw this for my trend line just because it also decreases, right? That's not the way that this line is decreasing. So that line would not be appropriate. Likewise, I also want some points to be above my line and below my line when I think of where this line would be. Otherwise, it would be symbolized as too high or too low if it just matched through. So I just kind of want to make it go through the middle. I want to have some points above it, have some points below it, and then I can usually use that line to estimate some values, but I think that's tomorrow's lesson. And I don't want to get too far ahead of myself here, thinking about what I'm telling you and I'm not telling you. So, yeah, so really today is just that general idea of relationships, that idea of a line of best fit. I'm going to have some vocab for you tomorrow, stuff like that. And then I think Wednesday, I'm going to talk about, I'm going to try to use I've never done that before, like the screencastify, like one of those. But I really want to show you how to use Desmos to actually be able to do this and have it calculate your line of best fit for you. So I'm probably going to try something like that to kind of show you the technology. And then if you have a graphing calculator, I'd like to show you on there too. It's going to be a little bit harder to do, but I'm going to try to figure that out. All right, cool. That's really it for me. Hopefully it's nice and easy today. And then, like I said, we'll learn some more vocab and stuff as we talk about these through Wednesday. You guys have an excellent day. Let me know if you need anything.